lines, that is longitude by chronometer. Now in our first method, which was latitude by meridian altitude or MARPAS, we have seen that by obtaining the altitude of a body at the time of meridian passage, we are able to obtain a position line which matches with the latitude of the observer, and we call it observed lat. Now the meridian passage method is very quick, easy and convenient to do. But there is one restriction which the meridian passage method has. And that restriction is that any particular celestial body will come on our meridian or cross the meridian or pass the meridian at only one particular time in a day. Taking the example of the sun, you see sun rises on the eastern horizon in the morning. Then it crosses the meridian around noon time, meridian passage time. It crosses over to the western side of the observer, and then eventually at the evening time it sets on the western horizon. So you see during the entire day the sun crosses the observer's meridian only at one particular time, and we can use the meridian passage method only at that instant. Now, if we want to use the body to obtain a position line before meridian passage or after meridian passage, we need to have some other method. MARPAS cannot be used there. So this is exactly where the next two methods come in. First method is the longitude by chronometer method, and the second method is the intercept method. So these are the ones which we are going to discuss now one by one. Now, first of all, coming to longitude by chronometer. As is clear from the name, this method tells us that we can obtain the longitude of the observer if we have the chronometer. Chronometer basically means GMT. So the name of the method tells us that if we know the GMT and we observe a particular body, or we take the site of a particular celestial body, we will be able to obtain a longitude. So that is the essence or the meaning of the method, longitude by chronometer. Now, one important thing to remember here before we proceed into the method, that the longitude which we obtain is not the fixed longitude of the observer. So obviously a doubt will arise in your mind, then what longitude it is. I will explain it to you once we reach up to the diagram of this particular method. The longitude is where the PL cuts the DR latitude. So it will be clear to you once we complete the procedure and we draw the diagram that this longitude is not the fixed longitude. So anyway, first of all, let's see what all information is provided to us in these type of questions, and what is the method, what is the formula which we use to obtain the position line. Now, first of all, let's go into the information which is provided. The info provided in these questions is the date and time of observation. The time may be given as GMT straight away, or they may give us the chronometer time. Obviously, if the time is given as chronometer time, it will have the chronometer ambiguity, and we will need to resolve the chronometer ambiguity. So for the chronometer ambiguity, a AM or PM indication is given to us in the question. Now the second information which is provided to us is the sextant altitude of the body. Along with the sextant altitude, they give us the index error and the height of I. Both of these are required for altitude correction. And the third thing which is provided in these questions is the DR position, the DR latitude and the DR longitude. So this is exactly all the information which is available to the navigator when he takes a site. He will be able to find the exact date and time when the site is taken. He will be able to get the sextant altitude of the body. He will know what is the index error of the sextant. He will know what is my height of eye in this particular condition of loading. And he will also know what is the DR position of the ship. So this is the information which is given to us in the question. Now, how do we proceed ahead? Now, the first thing which we do is, if it is chronometer time, we resolve the chronometer ambiguity and we get the exact GMT date, hour, minute, and second. Once the exact GMT is available to us, we enter into the almanac, and for that particular body, we get the GHA of the body. We get the almanac information out. So when you look for GHA on the daily page, you will be able to find out the hourly GHA, and from the increment table, you will be able to find out what is the increment for the particular minute and second of the time which is given to us in the question. And if the body requires a V correction, the planets and the moon, they both need the V correction also. So we can get the value of hourly V correction from the daily page, and we can get the increment from the increment table under that particular minute for which the GMT is given. So the V correction increment is also picked up if required for that particular celestial body. And once you combine all three of them, increment is always added, whereas V correction could be plus or it could be minus. It is negative only for one planet, that is Venus. It could be negative, it could be positive. However, in most of the pages in the 1992 almanac, selected pages which we have, the V correction for Venus is in negative. For all other bodies, the planets Mars, Jupiter, and Saturn, as well as the moon, the V correction is always positive. So increment is always added and V correction is applied as per the sign. And once you do that, you will get the accurate GHA of the body. So this is the first step. We obtain the accurate GHA of the body. Now, once we have the GHA with us, we also have the DR longitude known. DR longitude is given to us in the information. So when we apply this DR longitude to the GHA, we get the LHA of the body. So we find out the LHA of the body. Now with this LHA, we write the word approximate. So you can put a bracket and write along with that LHA as approx or approximate. Now why are we indicating as approximate? The reason for that is that we have used the DR longitude to obtain the LHA. Now DR longitude could have errors in it. So that's why the value of LHA will not be accurate. The GHA was exactly accurate for that particular date, hour, minute, and second. However, there could be an error in the DR longitude, giving an error in the LHA also. That's why we have written approximate here. The second reason is later on in the question, we will be finding the exact LHA also. And just to distinguish between the two, we have marked it as approximate. Now, once LHA is known, then we go into the almanac again. The second information regarding the body which is given in the almanac is the declination. Now from the daily page, from the date page, we will be able to get the hourly declination for the particular GMTR. We will also get the value of D correction from the daily page itself. And when we go into the increment table, we can find out the increment for the D correction for that particular minute which is given in the GMT. Once applied, it gives you the accurate declination of the body. Beta, any doubt up to here?
No, sir.
No, sir.
Very good, beta. Great. Let's proceed ahead. So we have obtained the GHA, approximate LHA, and the declination of the body. That is step 1. Now moving on to the next step. The next information you see we have is the sextant altitude. We will correct this altitude now. We will first apply the index error. If it is on, you put it off. If it is off, you put it on. Then we apply the height of I using the dip correction. The dip correction is always negative, obtained from the table given on first page of the almanac. And once these two corrections are applied, we obtain the apparent altitude of the body. With the apparent altitude, we can now enter into the almanac and obtain the total correction for the body. We are familiar with the total correction table of sun, stars and planet as well as moon. So we apply the total correction to the apparent altitude, and once applied, it gives us the true altitude of the body. So this is step number 2. So we obtain the true altitude of the body. Now, once we obtain the true altitude, GHA and the declination, we are now ready to apply the Long-Bicron formula. What is the Long-Bicron formula? The Long-Bicron formula says cos of P. This is the same P which we saw in azimuth calculation in the ABC method. So P is basically angle P of the PZX triangle, and it is derived from the LHA of the body. It could be equal to LHA or it could be equal to EHA or 360 minus LHA. So cos of P is equal to sine of true altitude minus plus sine of latitude multiplied by sine of declination whole divided by cos of latitude multiplied by cos of declination. Now a couple of things in this formula. P, as I already told you, is obtained or is the same as we used in the ABC method. P is either equal to LHA or P is equal to 360 minus LHA. In this case, we are going to calculate the value of P here in this formula. The true altitude, first term is sine of true altitude. The true altitude is already known. We have corrected the sextant altitude and obtained it. Then we see a minus plus sign. Now, what does this minus plus indicates? It indicates that in this formula, we will either use a minus here or a plus here. Now, which one of the two symbols is to be used? The upper symbol in these kind of equations, upper symbol is always used when the following terms, that is latitude and declination, are of the same names. And the lower symbol is used when the following terms, that is latitude and declination, are of the opposite names. So in this particular case, when latitude and declination are of the same name, we will be having the upper sign, which is a minus in this case. And when latitude and declination are of the opposite names, we will have a lower sign, and that is plus. The latitude used in the formula is the DR latitude. dr latitude is available to us as dr position is known. Then we have declination. Declination has been calculated from the almanac information. We have the accurate declination with us. In the denominator, again, we have the latitude for which we use the dr lat and the declination which is known to us. So you can see in this formula, all the terms which are there on the right hand side are known to us. So with all these terms known, we put them into the formula, and with a single step calculation in the scientific calculator, we will be able to obtain the value of P. So we calculate the value of P using this formula. Now this is a very important formula. It is to be memorized by heart. So please memorize this formula. The only way this question can go wrong is if you apply the formula wrongly. Otherwise, the question is pretty straightforward, straight and simple.
Sir?
Now, once you obtain the value of P, go ahead, beta.
Sir, now here we are finding the value of P.
Yes.
And from P we can find out LHA.
Yes.
So what is the need for finding out LHA approx?
अभी पता चलेगा बेटा. From this formula, from this value of P, now we can obtain the exact or accurate LHA. See, we calculated the LHA using the dr longitude also, but that was approximate. Using this value of P, we can now calculate the exact or accurate LHA. Now, when we find out LHA from P, one doubt which is going to arise in our mind is whether P is equal to LHA or P is equal to 360 minus LHA. Now, this doubt does not arise when we find the value of P from LHA, because we know when LHA is less than 180, P is equal to LHA. When LHA is more than 180, P is equal to 360 minus LHA. But in this case, the value of LHA is not known to us in the first place. So we don't know whether P will be equal to LHA or P will be equal to 360 minus LHA. So how to determine? Now this is where the approximate LHA comes to our use. Now you have a look at the approx LHA. If the value of P is close to this approx LHA, that tells you that P will be equal to LHA. And if the value of P does not match at all with the approx LHA, you do 360 minus P, and you will see whatever answer you get, it will match with your approx LHA value. Usually 90% of the questions, this will be within a degree. That means whatever LHA you have calculated, you will get one of these values, either P or 360 minus P, within a degree of the approx LHA. So it immediately gives you an indication whether P will be equal to LHA or P will be equal to 360 minus LHA. So repeating once again, whatever value of P is obtained, compare that value with the approx LHA. If both of them are matching or they are close to each other, you take P equal to LHA. And if both of them are not matching, you subtract P from 360, get 360 minus P, and you will see that that value is going to match up with the approx LHA. So this tells you that in this case, LHA will be equal to 360 minus P. So clear now, beta?
Yes, sir, clear. Thank you, sir.
Okay. Any doubt up to here, beta?
Sir, how much should be the difference between the values of P and LHA for it to be subtracted from 360 degrees?
Beta, as I told you, there is no hard and fast rule about it. But 90% of the question you will see that they will be within a degree. The approx LHA and the accurate LHA should be within a degree. Okay. But it all depends upon what was the error in your DR position. So there's nothing exact figurative value for this.
Sir, if the LHA approximate is less than 180,
Right. Beta, go ahead. If approx LHA is less than 180, then बेटा कुछ पूछ रहे थे?
sir, I was asking that if LHA approximate is less than 180, then we can take it like the new P which we have got from the formula. Then we can take it P is equal to LHA.
Yes बेटा, you can do it that way also. आपने यहाँ पे P की वैल्यू निकाल ली है. अब आप ये पता करना चाहते हो whether it is equal to LHA or it is equal to 360 minus LHA. Have a look at approx LHA. If it is less than 180, that tells you P should be equal to LHA. That way also it can be found out.
Okay, sir, thank you.
Okay. Okay, so shall we move ahead, beta?
Yes, sir.
Okay, great. So this is how we obtain the value of LHA from the value of P. Now, once LHA is obtained, we have the accurate LHA now, which is calculated using the Long by Cron formula. We can now compare this LHA with the GHA of the body. The GHA of the body has been already calculated earlier, found out from the almanac. So you compare this accurate LHA or the exact LHA with the GHA of the body. And when you compare both of them, their difference gives you the observed longitude. The difference between GHA of a body and the LHA of a body is determined by the longitude of the observer. So when you have both LHA and GHA known to you, you will be able to easily find out the longitude from their difference. Now this longitude which you obtain from the difference of GHA and LHA is called as observed longitude, because this longitude has been obtained by observing the body or by taking an observation of the body, which we call as sight. So we have obtained the observed longitude here. This was the name of the method, longitude by chronometer. Now, as far as the position line is concerned, only finding the observed longitude is not sufficient. We also need to find out the direction of the position line. We have a reference point now from where the position line passes, that is the observed longitude, but we also need to know what is the direction in which the PL lies. So for that, we need to calculate the azimuth of the body. In case of celestial bodies, the position line of the body, position line obtained from the body, always lies perpendicular to the azimuth of the body. So always remember, in case of celestial observation, the azimuth of the body is always perpendicular to the position line. So if you want to find out the direction in which the position line lies, find the azimuth of the body and perpendicular to it, 90 degrees away from it, is where the PL will pass or lie. How do we get the azimuth of the body? Now for the azimuth, we use the ABC method. We are aware in the ABC method, A is equal to tangent latitude upon tangent P, named opposite to latitude if P is less than 90, and named same as latitude, that is unusual cases, very few cases. It is named same as latitude in case P is greater than 90. So after A, we obtain the value of B. B is equal to tangent declination upon sine of P. Declination is known to us. The value of P is also known to us. We have calculated P using the formula. Same way for A, the latitude used is the TR latitude, which is available in these questions, and the value of P is obtained from the formula. So B, once calculated, is named same as declination. And once we get A and B, combining A and B together gives us the value of C. By combining, I means they could be added or subtracted. If they are both of the same name, both are added up and the name is retained. And if they are of opposite names, then the smaller value is subtracted from the bigger value and the name of the bigger one is retained for C. Once C is obtained, we put it into the formula of tan azimuth is equal to 1 by C into cos of latitude. So we have the value of C now obtained from A and B, and we have the latitude which is given to us in the question. So using these two, we obtain the azimuth of the body. This azimuth is in the quadrantal notation. We obtain the quadrant using the name of C and the value of LHA. So once the azimuth is obtained, we are aware now that a celestial position line is always perpendicular to the azimuth of the body. So adding and subtracting 90 degrees gives us the direction in which the position line lies. So we have obtained the direction in which the PL lies, and we have also obtained the observed longitude. These are the two items which are required in these questions. And when we have these two items known to us, we are able to plot this position line easily on the chart. You have a reference position, which is given by observed longitude. And what about the latitude? The latitude used is the DR latitude only. DR latitude and the observed longitude gives us the reference position from where the PL passes, and the azimuth gives us the direction of the PL because we know that PL is always perpendicular to the azimuth of the body. Now, beta, please take a screenshot of this particular page and save it on your device. Go ahead.
Sir, one doubt.
Bolo, beta.
Sir, regarding the naming of this azimuth, the second name, east or west, can you please tell one more time, depending on LHA, how are we going to name east or west? Second name in azimuth.
Okay, बेटा. So you are saying that ये जो azimuth हमारे पास आएगा, उस azimuth की हमें naming कैसे करनी है, especially the later part of it, whether it should be east or west, right?
Right, sir.
Okay, बेटा बहुत simple है. If your LHA is less than 180, LHA less than 180, it will be named west. And if your LHA is greater than 180, it will be named east.
Okay, sir. Thank you.
Okay, it was the same thing which I did in azimuth also. In azimuth formula, same thing we discussed, that LHA less than 180 west, LHA more than 180 east. This is because LHA is a westerly measurement. It is a westerly R angle.
सर एक बार ए की नेमिंग का बता दोगे वापस?
ओके, बड़ी सिंपल है बेटा। अच्छा बेटा, पहले मुझे ये बताओ कि जो मैंने आपको एजीमुथ करवाया था वो स्लाइड का स्क्रीनशॉट आपने रखा हुआ है?
नहीं सर।
सर
मैं बता दूंगा, बट इफ यू हैव दैट स्क्रीनशॉट विद यू, नो डाउट विल अराइज। ओके, अब आपने
A is
बेटा
always named on the name of latitude, ना?
नो बेटा, नो, इट इज नॉट लाइक दैट। मैं तुम्हें दोबारा से दिखाता हूँ वो। पहले मुझे ये बताओ कि इसका स्क्रीनशॉट आपने सेव कर लिया डिवाइस पे?
Opposite to that of latitude, except when LHA between 90 and 270, right?
Yeah, that's right. So इसका स्क्रीनशॉट सेव कर लिया बेटा?
Earlier.
यस
Okay.
सर, कर लिया।
ओके बेटा, ओके, ग्रेट। सो कुछ एक चीजें मैं आपको सेव करने के लिए बोलता रहूंगा, सो दैट you have them ready with you, so they will help you in case you get stuck anywhere. So let me show you now. एक बार मैं azimuth भी आपको दिखाता हूँ। So this is the complete method. How do we obtain a position line using the longitude by chronometer method? Now this formula for long by chron, that is cos of p is equal to sine of true altitude minus plus sine of latitude, sine of declination, whole divided by cos of latitude, cos of declination, should be memorized. And you should be certain that you are applying this formula correctly. Making a mistake in this formula will be considered as a principal error at this particular stage. Because you have been using this formula right from pre-C time. It is there in pre-C, it is there in second mates. So make sure that you don't make any mistake in the formula. Now, just to give you a understanding of this method, though it is not required in solving the question in any way, but if you look carefully in this formula is nothing but the cosine formula applied to the PZX triangle. So this has been derived from the cosine formula only by applying it for angle P in the PZX triangle. But I don't recommend deriving this formula from the PZX triangle in these questions. You should memorize it and apply it straight away, because it is going to save you a couple of minutes. And time is really important in these questions. You should be choosing a method which gives you the answer in the quickest possible time. Time is a scarce quantity in phase 1 exams, and many of the candidates who are not able to pass the phase 1 exams is not because they did not know how to attempt the paper or how to solve the questions. The questions are, if you have practiced them, pretty simple and straightforward without much of complications. The main thing is completing the paper in time. And if you are not able to complete it and you leave some part of the paper unattempted, it surely puts you in the other side of the passing line. And with the passing percentage being also very high, it is very critical that you use the method which gives you the answer in the least possible time. So this is the cosine formula only, but you should memorize it and apply it as such. Now, before I go ahead, let me show you the azimuth formula first. How to compare the LHA and GHA to obtain the longitude in this question. I told you in this question that we get the value of P from the formula which gives us the LHA. We compare LHA and GHA and obtain the longitude. Now how to compare both of them? Should we do LHA minus GHA or GHA minus LHA, or what should we do? Or we add them, we subtract them. So let's see a very simple and easy procedure stepwise. Compare the LHA and GHA. Look at the values of LHA and GHA. You will find one of them will be smaller than the other. One will be greater, one will be smaller. So irrespective of which one is greater or which one is smaller, you subtract the smaller one from the bigger one. Or in other words, you find their difference. You have the GHA with you, you have the LHA with you, find the difference between them. In case GHA is best or greater, you give it the name as west. And if GHA is least or smaller, you give it the name as east. So you know we have that idiom, longitude west, GHA best. Longitude east, GHA least. So we are using that same idiom here. If the GHA is best, name the longitude as west. And if the GHA is least, name the longitude as east. So once it is done, now the last thing, in case by following the previous two steps, you obtain the answer which is greater than 180. Now our longitude cannot be more than 180. We have two hemispheres, eastern and western hemisphere, both stretching up to 180 degrees. So in case you get an answer greater than 180, subtract it from 360 and change the name. We had done the naming in step number 2 here. So if the value is greater than 180, you subtract it from 360 and you also change the name. The value coming more than 180 basically tells you that it is in the other hemisphere. So you subtract it from 360 and change the name. So this is the simple procedure. Compare both of them, find their difference, subtract the smaller one from the bigger one. GHA best, longitude west, GHA least, longitude east. If the answer is greater than 180, subtract from 360 and change the name. You have the longitude known to you.
So clear, beta? This is also clear?
Yes, sir.
ग्रेट, मैंने इसका भी एक स्क्रीनशॉट आपके चैट में डाल दिया बेटा. डाउनलोड इट, जस्ट कीप इट ऑन योर डिवाइस. Okay. Let's move ahead. The only thing which remains now is plotting the position line. So let's see how the position line is plotted.
Let's now see how do we draw the position line obtained with the longitude by chronometer method. We have basically obtained or calculated two things here. One is the observed longitude and second is the direction of the PL, which is perpendicular to the azimuth of the body. So how do we go ahead and plot this position line on the chart? We use the dr latitude. Let's plot the dr latitude in our diagram. You see the dr latitude plotted. Now we have also calculated the observed longitude. So let's plot the observed longitude also. You have this vertical line representing the observed longitude. Now this position, that is the dr latitude and the observed longitude, is the position from where the PL passes. Now once you have this, now you draw the azimuth of the body. We have obtained the azimuth also. Let us assume that the body was somewhere here, and if you plot the azimuth, it will be represented by this red arrow line. Now once the azimuth is plotted, we know perpendicular to the azimuth is the position line. So at right angles to the azimuth of the body, draw the PL. So this green color line which you see is the position line, and this is how it is plotted. It is also called as a LOP, that is line of position, or a PL, that is position line. So this is how we plot the position line on our chart or on our plot.
Okay, so any doubt, beta? Any doubt in this complete method? Anywhere in any of the steps?